Hi, I am Michael Julius Armoredo, and for this video, I'll be demonstrating by solving a problem or a task in our automation course, and the task is about filling and draining tank operation using the compare, move, increment, and decrement function blocks in the CX programmer, as well as creating a design in the CX designer. So I'll be sharing my screen now. So this is the task, the classwork 2-1, which we will be using the compare, the move, the increment, decrement for the function blocks in the CX programmer. And then we will create a design in this CX designer. The CX designer will use the program in the CX programmer. So the user will have a graphical user interface that can easily control and monitor the program. So this is the task, filling and draining tank operation, and the requirements are in the operation. I will discuss the whole operation of the process. I will create a setup that shows the GUI display with labels and addresses. And the GUI addresses, I will show the list of HMI addresses and descriptions. And in the wiring, I will show the complete input-output wiring of the system. And in the assignment table, I will show the PLC input-output port assignments and descriptions. And in the PLC ladder diagram, I will show the program and provide remarks or comments in every rung or possibly every component. So I will just close this for now. So here we will start with the CX programmer. So create a new device. So in this device, I'll just name this as CW2-1. And for the device type, I'll just use the CP1H, which was available in Mapua. And the network type, the USB. So we are now in the section 1. And in this section, we will program our ladder diagram. So in the CX programmer, it is just programming in inside the microcontroller, where we can program the ladder diagram for the PLC solution. However, we can also see the other symbols, the tables, and the memory. And here we have the components, input outputs, the A, the timer, the C counter, the IR, DR, the data, TK, H, and W memories. Then we have this program. In this program, we can create new programs. So let's say we want another program for another classwork. So we can add this another one later. But for this program, this is um, this is our program for now. So this program will have sections, and it will read the sections, or it will follow the program, execute the rungs for rungs one at a time per section from the top to bottom. So it will start with the section 1, then the end, up to the end. So we will have the symbols here, and the symbols, we will have the components, the data types that those components are, and what address or value that we will be using for those, and their rack location. If they're input, we will know them later, and their usage, and I will try to input some comments later. So I'll just rename this section as filling and draining tank operation. So as part of the sequence or the operation, we must have a start that will start the whole process. So for that, I'll be using a normally open contact, and this normally open contact is represented by the switch, the the input switch. So this let's say this is push button start, and this should not actually be here in the ladder diagram. It is in the outside, but for this program, we can include this, but the address value should be the input. So for this CP1H device, the input, the addresses for the inputs are in the range of 1.0.1.00 per channel 1 bit 0 up to 16. So 1.00 up to 1.0. Um, I'll replace that. The input are starts with 0, channel 0, up to bit 0 up to the bit 16. So for the input, I will use 0.00. So I'll just enter the addresses and values in the comments so I can see their addresses while working this program. And for this start, this will start the whole system. So I will just make the rank 0 as not part of the pattern, but it will latch only a value that can start the system. And here I will also include a stopper. So in the stopper, it can also be a push button stop or part of the sequence that once the whole process has been completed, it will stop the operation of the start, and we can continue again when the push button start has been pressed. So for now, I will not be including a value or address value for this connection, new symbol, normally close contact, but this is named as stop. And since I will be using the rank 0 as the initial rung to start the whole process, I will need to use a coil. So just name this as capital start. And for this address value, I will be using 5.00 or any values other than 0 or 100 because they are used as input or outputs. And since we want this value to keep open even when the PB start is no longer pressed, we can continue the program. We will be latching this value. So this is start. And using the same address value as the coil, this contact will close once the coil is high value. So for this program, we will be using three data memories. One data memory for the current value of the tank levels, which ranges from 0 to 100. Then another data memory for the set value that will be specified later to pause the program, pause the filling of the tank, and another value for ending the process. So as part of the task, the initial value that was given was zero water level. Then it should once the PB once a push button has been pressed. So let's say it is this PB start. It will now start to fill the tank. Then once it has reached 100, it will now stop the it will now stop the pump to fill the tank. And after 2 seconds delay, it will now drain the tank up to the zero water level. So we have the range of the water tank from 0 to 100 water level, and we have the 100 the water level 100 as specified for the maximum um, the the maximum water level that will stop the program or the system to stop filling the tank, or it to pause it is for pausing the pump. Then we have another data memory to stop the whole process, which is indicated by zero water level. So we will include new program. So since we will be using three data memories, we want to clear those data memories with specified value in the beginning. So let's say move a zero value uh, data zero, data memory zero. But we want this program to only do it once a signal has been sent to this function block. So we'll be using at mode number value zero hexa value, then uh, and the destination is zero. So the the D0 is the memory destination of current value, current level, tank level. Then we'll need another two, but in this case, we'll do this as since we have a 100 water level, we can use a hexadecimal value 64. So 4 plus 6 times 16 will be 100, but we can just use a bit. So in this case, the decimal, the symbol to indicate the numbers decimal is this symbol, end symbol. So 100 decimal. So let's let's say this is destination D1. So instead of memory destination of the current tank level, it will be the point set point value to post the program, because as part of the sequence it will start with 0, then it will fill the tank once PB has been pressed, and it will when it reach the 100 water level, it will pause for 2 seconds, then it will stop. It will stop when drained up to the 0 water level. So same value. We can just use a number sign 0 or end 0, since this is a 0 for both hexa and decimal. But the destination is 2. So we have 3 data memory destinations. So the 2 will be the dash value to stop the um, draining of tank. So this is for the first run to initially set up the program. Later, I will include the address for the stop. But for now, let us move on to the next rung. So as part of the process, once the PB push button has been pressed, this start coil will latch. So when it is latched, it will now start the peeling of the tank. So in this case, we'll need a new component, ladder diagram, start. So this start will enable a increment. So we have the function block increment, increment um, increment by bit by one value to the data memory 0. So it will increment this data memory, but we want this increment to be um, progressive, and for that we will be using another component. So ladder diagram, we need a pulse contact, and this for this pulse clock, I'll be using the 0.2 seconds, so we can have a shorter long time to wait until this will increment another again and again. So here with this, we increment the the memory destination D0. However, when it is open, it will continuously increment this value, which it could easily exceed the maximum, and it will go up to 9999 value. So for this part, I'll be using the at value that it will only increment. It will only do the function once a signal, only at the positive signal that it it receives, not while the signal is being sent or while it is active or turned on or high value. So So for this part, we also need to have an output that could tell us, or that could help us indicate that this program is filling the tank. So for this part, I'll be using an output component. But so as I explained, that the input addresses are zero, starts with zero, then dot 00 up to dot 16. Then we have the output for 100 dot 00 up to dot 16. So I will start the first address, then um, this device should be named as bulb, water bulb or pump indicator. Then here the address will be 100.00, and another comment will be the the that this component indicates that the tank is being filled. So we now move on to the next rung. In the next rung, we want to check if the incremented value is now equal to the set value that we want to pass the program. So in this case, the 100 decimal 100 water level. So for this part, it will we have the compare the the D0 and the 1. Memory destination of the current tank level, set point value to post the program. So to power this or to start this program, we have the start. So once the start is touched, it will both start the increment and the compare. And in the compare, we will be using the equal. So since we are comparing two values, we want to compare if they are equal. If they are equal, we will pause the increment or the peeling of the tank. So ladder diagram P underscore EQ or for equal. Then we have the here we have the pause. So this will pause the increment and and the the compare, since we'll be moving to the decrement later. So for this part, we'll be using an output contact or relay. But since we use the memory address 5.00, so now I'll be using 5.01. The address will be 5.01, but the name is pause, and the address 5.01. This is but we also want to latch this value. So once this is continuously paused, so we forgot to include a contact. So the diagram And another pause here. So we have pause for the increment and pause for the water valve. As you may have noticed, I removed the connection from the pulse to the water valve. So we know that the indicator is continuously on even without the pulse, but we want the pulse to only affect the increment. So we have this pause, then we want to latch this pause. And we also want to stop this pause once the full program is completed. So, so this stop is the same as this stop component. I will later complete this program. So we are now done with the increment. So again, as the PB, the push button has been pressed, it will latch the value. While latching the value, it will clear the values, the data memories for the current current tank level for the maximum set point value that will pause the program, and for the minimum last value to stop draining the tank and the operation itself. So we can change these values later on, the 100, the 0, and the 0, whenever we want to change the set point values. And while after setting or clearing the memory value, memory destinations, we will now start with the increment. And in this increment, it will it will increment every 0.2 seconds. And for while incrementing, the indicator is turned on, and while it is turned on, the our program is comparing the current tank level to the set point value if they are equal, and it will pause the program if they are. So this should be close contact, normally close, so it can work while pause is not working. So these two ranks should explain or should solve the peeling operation of the tank. So now we will go um, with the draining. So for this part, um, I'll be using the contact of the pause. So we divided the program into two. The first part where the start will it will be um, the main process to up to the set point. Then after that, the start will no longer have any effect, and for that we'll be using the pause. And for the pause this will be the ones that can enable the following process. So we'll have the start, then the pause. But once it has been paused, we should include a timer since it is paused. So for this pause, we have the timer, um, timer 0, and the set value is 20, since a part of this task is to include a delay or a pause of 2 seconds. Each value will be 0.1 seconds, so a value of 20 will be 2 seconds or 20 0.1 seconds. So this is just this process. Then we have the another one, the pause. For the later following ranks, we'll be using the pause that will indicate that we are now in the second part of the program. So ladder diagram pause. Another one. After the 2 seconds delay, we have the draining. So the draining will be in the form of decrement. So we should have the decrement. Similar case with the increment, we will have the at value that only when the positive signal is supplied, then it will decrement. BCD decrement the value of the D0 or the memory destination, the current tank level. And to decrement, we will need to have a pause or a pulse. Same pulse of 0.2 seconds. And to enable this, we need to indicate that the timer is completed. So another diagram. So this will be the timer, this timer. So this is just a delay. So this is the delay part, the delay timer. Then we need to have another indicator similar with the increment or the peeling. We have to have the water valve indicator, but in this case, we will be using a water drain indicator or drain valve drain valve drain valve indicator. So this will be named as 100.01 since we use the .00 in the water valve indicator. So this indicates that the tank is being drained. So the indicator should not be in the pulse. So we'll remove that and include this here or in the pause after the pause. So while it is being decremented in the program, it tells us that it is being drained. So same case, we have the compare. So we should also compare if they are now equal to the last value, the number water level 0. So we can just copy. But for this case, we'll be using the pause. So instead of data memory 1, we will use the 2. So the last value to stop the draining of tank. And we also um, use the equal, and instead of pause, we will now stop. So this should be stop, and this stop will be set as 5.00 as just an internal plug in this program. This the red color indicates that there is something wrong with the program, which we can see that there is no address or value yet. So we will just go to the symbols, then name the address as 5.02, 5.02. Since we use the 5.00 to the start, 5.01 to the pause, then 5.02 should be to the stop. So here 5.000102. So we can go back and the program is fine with the 5.02. Since we have the stop, this should complete the program. So let's try. So once we set this value as on, it will move, it will set the data memory values and that's this start values, start coil. And once this contact is closed, it will now start to increment up to the D100. Why? Because once it is compared to the value 100 that is stored in the destination one, it will now pause and this will now be closed or open. The contact will now be open and it will be latched. Then we can continue with the timer. And for this timer, we will have 2 seconds delay. Then it will now start once the timer is fulfilled. Once the timer function block, the 2 seconds delay is fulfilled, we will now start with the decrement. And while decrementing, it will be compared, and once it has been reached or the value of the current tank level is equal to the set point of the last value, it will now stop the program. And we can now start again if the push button is pressed. So set on, then set off. So we can see that the X value is increasing, and if it reach 64, there we go. We have a pause of 2 seconds, then we have a timer delay, and then we have decrement. It will decrement up to 0. Then it should stop. So we now stop. So what if we um, continuously press the push button start, and then this program should continue again once even the um, when the stop is called. So timer, delay, decrement, So it stopped, but in this case, it is still continuing since the push button start is continuously set on. Then 2 seconds delay. You can also view this in the decimal. So I'll just press the start again. So the value 30, 40, 50, 60, almost 100, 80, 90. Then we have 2 seconds delay, then decrement. 40, 30, 2, 1, 0. Then we are done with the ladder diagram. So this ladder diagram is uploaded to the PLC, to the um, so this will be internal program, and we will now go to the design. So in this design, we will design a GUI so that the user can press a button, the start button, and it can see that the tank is being filled, as well as we have the indicators and the labels. So for now, I'll just save this and move on to the CX designer. So we can use any of this touch screen, but for this part, I'll just use the 5-inch. So name this project as CW2-1. Project title, filling and draining tank. So this might just take a while since I have a slow computer. I will restart I will create a new file since this project has already a built-in design. So just create a new project. So this just new project and system version. So in this case, I'll just use the 15-inch. So here we go. we have this screen. So zoom out, zoom fit. So um, we have the push button. So this is important that we have the push button. Then we have the tank. So for this tank, hmm, I will just use the bitmap because part of this CX designer, we can um, change the color or the shape of the any values that we have. But for this bit lamp, we have a different values for the tank. So as you can see, we can have these different types of tanks. So I'll just use this tank colorful, color gray or silver gray. So here we have a figure, the tank. Then we should have a pump or a bulb for the input. So another bit lamp. So we need to have a pump or a bulb. Here we have the pump. Since we use pump colorful, tank colorful, I will be using also the pumps colorful. This is for the off state. Then once it is on, we want this to be indicated that it is being it pumps water to the tank. So just use this in the bottom right. So it looks like we have the water pipes down here. Example, Maynilad. Then um, we have another bit lamp for the drain. So let's see the drain. We can also use the hoppers. So we have this shape that is not too large in the tank. So going back with the drain, we'll be using these pipes later. But we need to find something to describe the drain. Here we have the bulb. Since we don't actually have a drain part, so I'll just use the bulb. Same color as blue when it is on. So apply. So it looks like the tank is draining when this bulb is on. Since we don't have any actual drain, we can just use a bulb in the bottom of the tank to illustrate that it is draining. So next we should have the pipes that will connect from the pump to the tank. Here we have the pipes. First, we need to use the pipes colorful. Then we have the up, the gray for the up state and blue for the on state. So here we have the illustration that this pump is filling this tank. So we will later design the address for this pump to be the same, that it shows that it is indicating. It indicates or is illustrating that the tank is being filled. So next we need to add something that can describe the water level. So for this part, I use the level meter. So in this level meter, so use the just color blue for the 100, minimum of 0 to 100. Then we need to have a label. So this label will numeral display. So this can display the value. The label will be used here. So we have the comment. So this is start. So start push button. Object comment start push button. And the address that we used here, it should be start. So here 0.00. It is the input. So this is okay. Then we need we want to have a label of start. So we have the start push button. So we can change the shape to look so it looks better. Hmm. So this numeral display input. So as a comment is with um, display the current tank water level, water level. Display the current water level. So this is a decimal integer signed one word. Then the address. So we want this address to come from the data memory. So as we have here, we use the data memory, the 0 for the water level, tank water level. So we also want the data memory 0. So this is DM0. So we have this. Then we need to have another two for the maximum and the minimum. So this will be display the set point, set point maximum value, set point max value. Then instead of data memory 0, we will use data memory 1. So here, the set point value to post the program. Then in this part, instead of set point maximum, set point minimum value. And instead of D0, we will use D2, data memory 2. So this should be data memory 2. Okay, apply. Data memory 2. DM2. So additional part that I will just include is a LED that indicates that it is being it, it is being filled. So we'll just draw a connection. So it looks like this is connected to the to the tank. So similar case, um, this is water indicator of tank being filled, tank filling filling the tank. So the display address. So here we will base in the symbols. So we have the indicator here, the 100.00. So the water bulb, so this will indicate that it is filling or incrementing in the program. So common input output area with 100 with zero output. So 100 should be 100.00. Then in this case, it will be 100.01. 100.01. And the comment indicator that uh, is cleaning. So we can also this is the parts that we'll be needing, and we can also include that these components can vary in color when it is being filled. So let's just double check that all the important components have their own corresponding addresses. So this is the current water level. Then it will be based on here we have the data zero. It will based on the destination zero of the data memory. So DM0. So this is the same with this display. Um, the difference is that this displays the text value while this displays the percentage. So let's try running this right. So save all, and we can try to simulate using the PLC PT integrated simulation. So as you can see, we have the 0.00. This is the push button, the 100.00. This is the LED. Oh, here's the GUI. So this is the LED, the 100.00 here. The 100.01 is this LED for the draining. This indicates the draining operation. Then we also have the data memory 0, data memory 1, data memory 2. Then this is the other parts, the other components. So let's start. When I press the start push button, it should change the current value to 0. So it will clear as part of this program, it will clear that value. So when it is clear, it should be 0, 0, and 100. Then it will start peeling the tank up to 100. Once while it is peeling, the LED is turned on as part of my added features. Then once it has reached 100, it will pause for 2 seconds. Then it will drain. While draining, this LED is turned on uh, as part of my added features. So let's start. Hmm. So 102 seconds, then draining and LED. So I forgot to change these the addresses values of these pipes as well as these two. So let's just go back to the design. So instead of color shape, this will be copper blue. And this part of the draining process. And for this address, um, we want to this part to be included in this draining process 100.01. Although this should not be named um, with the output 01. This is just for the simulation. Again, this is just for the simulation display. So same with this part of the draining process, the 100 output 100.01. Okay. This LED is the also part of the draining process, but the output component is this. This is the bulb. Another output component of the program is this pump. So we only use the pump, the bulb. So these pipes and the pump is part of the healing process. So instead of 100.00, 100.00. So same case with all the other part. So 100.00. So I just use this part so that the tank, whether it is on or off, will not change the illustration. Since I won't change the display address, this is just the display address for this simulation. So this is the tank. So again, we have the input, the push button input. Then we have the operation. The main output will be these two. Another output will be to control or the pump, the for the peeling. Then one output for the draining, the bulb. So as we can see, there are only three input output components. So those are the three components. The um, other three symbols or coils are used as the internal plugs. Then um, this LED and then this display is just for simulation. So these are added features. This pipe should should light up blue when it is filling because I programmed that it has the same address as the pump. This is just for the sake of simulation. So let's save. Then move on to the redo the simulation. Restart. So we can simulate again. So these are the description or my description or comment for each parts. The PB start does not need any description since it is in the name itself. It is a push button to start and it is an input. So usage input address value 0.00 and in the main block /00. So these are the two outputs, the drain bulb indicator, water bulb indicator, the 100.01, 100.00, and this indicates that the tank is being drained or filled. So this is those two. It should be the pump is the indicator that is being filled, then the bulb is the indicator that it is being drained. The other parts are just for the sake of simulation. So let's go back to the process or the operation of this PLC system using this program of the ladder diagram. So once the start push button has been pressed, the um, the current value will be set to 0. The maximum value has already been set, and the minimum value to stop the program has already been set as part of the task, the 100 and 0 water levels. So once this has been pressed, the tank will be filled. It will be continuously be filled and up to the 100 water level. Once it has reached that water level, it will pause for 2 seconds. And after that, it will now drain up to the 0 water level and pause or stop the whole operation. Then we can also start again if we press the start push button. So let's try now. Start. 2 seconds, then it will now drain. Then it will now stop. Then we can also start again. I will change that illustration later. So this is being filled up to 100, then stop, then light on, and it will now drain. So this is uh, the operation. So we'll just change the ones the color shape. I'll just set this name with 10. or 7. So it will not be used in this program. So it will not change to this shape, and we can watch the simulation again. So let's redo the simulation. Start. It is now being filled. Then the light that indicates it is being filled is turned on. The current value is increasing, and it has reached 100. It has turned up, and there was a 2 seconds delay. Then it is now turned on, the light. Then we can see the valve should be connected, and it is now turned on to drain. So start again. There we go. We can see that it is now filling again. We can change the speed that it is being filled by using a different pulse speeds to the increment. Same case with how it is being drained. We can also change the set point values in this program. Similar case with the last point minimum values. We can use other illustration, pump, blower, or anything that can indicate that it flows water to fill a tank. Since we are simulating that a tank is being filled and being drained, and it is being controlled using a PLC system. So we have this simulation, this ladder diagram, and these symbols of inputs and outputs. So I have discussed all the requirements for this task, classwork or coursework 2-1 for the module 2, filling and draining tank operation. So stop share. So again, I am Michael Julius Armaredo, and for this video, I have demonstrated and performed a PLC or ladder diagram program and design using the CX1 Omron software for the task of filling and draining tank operation simulation. And thank you for listening. So this is all.